That's many flowers. As springtime starts, nature bursts in life, and then that's the beginning of the traditional year. As the year went on, the calendar would go through various seasons. In the summertime would be when the crops would be really, really growing. And that's in some cultures, there's a summer festival. And then later on, as the Earth keeps going around, North Pole is starting to tilt away. It's starting to get dark. And then you get to the beginning of the end of the growing season, the beginning of winter time. And that's when we traditionally had Halloween. So let's go over through this. So this is a traditional calendar. The vernal equinox is when the sun, the days and nights are equal, and the sun is beating down over the equator of the Earth. So in nature, that's the beginning of the cycle of life. That's when birth is happening. The symbolism we have are on the lower right images here. Nature is bursting into life. The other cycles are kind of fraternity symbols, the Easter bunny, Easter eggs, all of this, the fertility symbols, hoping that there'll be a great rebirth and lots of living things would come out of it. So as you go around, you follow the Earth going around, the midsummer day or the summer solstice is when the days are longest. So that's when we have the most light. Many countries, we don't have this, but they have a midsummer festival. May Day is often called. And these are some images of various midsummer festivals along the bottom. And then at the top left is an image of nature just growing away with all this sunlight. The calendar keeps going, and then finally the sun starts going away, and the nights get longer and the growing season ends. And that's the beginning of the cycle of death. So that comes from our Halloween. So the autumnal equinox is the start of winter. So the things are getting dark. You're starting to see the various symbolism from that time of the year. And finally, the darkest night of the year is right in the middle of winter time. That's December 21st. So that's when the nights are longest, and mostly it's dark outside. And there were festivals across Europe. There were pagan festivals that were started. They were called Saturnalia, and they started from Roman times. And that was a festival marking that this was as bad as it's going to get. This is the darkest night of the year. If you can make it through tonight, then things are going to start getting better. The lights are going to start coming back. So the symbolism this time of year are anything that represents light coming back. So this is a very nice picture of a Christmas tree with lots of lights in a dark scene. The other ones, these other kind of Christmassy images, have light that time of year. If you go northern part of the continental United States, the sun will get about that high, and it's cold, not very much sunlight. And then the symbolism here is light, bringing light to darkness. So this is that house on Chinaway. We all know what I'm talking about. So it's halfway between our house and that Kroger. So we get to drive by the traffic jam here just about every week or so. So it's interesting. If you drive by Chinaway, it's worth pulling over and walking up to the house because it's a multi-dimensional. It has a multimedia experience. There's a lot of things going on. So that's the seasons marked through things that are happening in the calendar. December 21st was the kind of leftover season. There was no Christian holiday that was right there. Christmas had not been set until the 4th century, the date of Christmas and the year of Christmas. And it was decided they had this Roman festival, it was a pagan festival, this feast of light. And then some stories have that Augustus was the one who proposed this. Others say that's apocryphal, but early in the history of Christianity, it was decided to put Christmas on this day because this was the return of the sun, and there was the symbolism. So this was the end of December. So that was only decided 3 or so centuries after the life of Christ. So Saturnalia itself was the festival of light that was in the darkest night of the year, a Roman festival. People, so this was Roman times, back around the year 0. And the symbolism in this image are things like sort of people dancing around. There's a lot of mischief going on. It's nice and dark and cold outside. And so this is what became the date of our Christmas today. So the symbolism, again, back to the house on Chenoy, is light returning to darkness was this time of year. Okay, so that's where Christmas time came. When was it really? It was that decision was made about the 4th century. The imagery, if you go back to what was going on at the birth of Christ, there's the shepherds tending the sheep, because that was what Mary and Joseph encountered. And so if you go back and look through anthropology, what time of year, when would be shepherds tending the sheep? The answer is that shepherds don't stay out with the sheep all the time. So these are various medieval drawings showing the birth of Christ. And some of them, this one is spectacular, how this artist has used the light playing on the faces. So you can find many of these images on Google Images. So the shepherds were tending their sheep. Shepherds don't tend the sheep 365 days of the year because they got better things to do at home. They come out and spend the days and nights with the flock during the lambing season. So that's when the mother lambs are having babies, that they're both very, very fragile, and the shepherd can help things along. Now, most likely, if the shepherds were tending the sheep, this would have been sometime during the lambing season, which is April plus or minus, something like this time of year. So maybe that's the time of year we're looking for. So Kepler went through this. These aren't my ideas. Kepler was a smart guy. He didn't know about telescopes that hadn't been invented yet, didn't know about planets and gravity because that hadn't been discovered yet, but he was watching the planets on the sky. So he decided, well, we got to figure out what was going on sometime in the springtime. The next thing is, what's the year? Well, you just think, well, it must be 10 AD or 1 AD. It must be simple, except there weren't any written calendars back then. And the thing you know for sure from the biblical records is that Herod the Great was alive. You don't know exactly when he died, but you know that he did witness a lunar eclipse, and he died before Passover soon thereafter. And we know when eclipses of the moon happened. We know that to great precision. We know about solar eclipses too. So those are times when the sun covers up, the moon is covering up the sun, it gets dark, or when the Earth's shadow blocks the moon, so that it gets dark. So there was this time in here was set by the fact that Herod did see a lunar eclipse, and then he died before Passover. So he would have died somewhere between March and April. So he was the person who ordered the census that drove Mary and Joseph to Bethlehem. So we're looking for something around April plus or minus a month, about roughly something like the year 4 BC, something like that. So there were some mistakes in setting up the year 0. So this is Kepler himself. You look at these old drawings, they look all stuffy and unappealing. You can't imagine people looking like that. You know, where did they get that color? How do you make such a thing? But he actually was a wonderful man by all accounts of the people who knew him, which makes him something of an exception of the founders of astronomy. So he had a family that loved him. He had a marriage that lasted his entire life, and he had a very large number of offspring. So he was a man who loved much about the world around him, especially he wanted to understand the planets. So over his entire life, just by watching the sky with his naked eye, the telescope hadn't been invented yet, he watched the planets move around in the sky, right, as if by magic. So gravity wasn't understood yet. What he figured out was how to figure out, he could predict by the end of his life where Mars was going to be in 18 months. And he could also figure out where Mars was 1,500 years before. And so his goal here was, by doing these laws, these really are planetary laws, he was going to figure out what was going on in the sky back around the year 0 AD. And he believed very powerfully in astrology, and he thought that somehow the planets might indicate what's going on. So over his life, he just, by watching the sky, we were doing the same thing. He had no telescope. Watching the sky, he figured all this out. First of all, they had believed that planets moved in perfect circles around the sun after Copernicus. The reason was circles are perfect and everything up in the sky had to be perfect. Kepler realized they're not perfect circles, they're kind of football shaped. They're kind of squashed out. So our distance to the sun is on average 93 million miles. But right now, this time of year, we're a couple million miles closer to the sun than we are in the summertime. We're farther from the sun then. It's not a perfect circle. The distance to the sun has nothing to do with our seasons. This is tilted our spin axis. And then, so this told him where the planets were. Next, you want to figure out how fast they move. And so he figured this out. Don't memorize any of this. Our poor Astronomy 191 students pay tons of tuition money to hear me give this same slide. You're getting it for free. That's a great bargain. And then finally, the planets in bigger orbits have longer periods. So if you know the path, if you know a car is going due north at 50 miles an hour, you know going due north in 50 miles an hour, in 2 hours, they'll be in Cincinnati. So you can figure, so what you can do, if you know the path, the direction, and if you know how the speed changes along the path, you can figure out where it used to be and where it was. So you want to figure, and where it will be. You want to figure out the future so you can sell the local ruler a horoscope to figure out when to launch wars. He wanted to figure out the past so he could figure out what the Star of Bethlehem was. So he could predict with this lifetime of work where the planets were in the past and where they will be in the future. It was only 100 years later that Isaac Newton, another very unsavory fellow, if you look at his history, Kepler is the exception, explained that this is just an inevitable, it inevitably happens from the way gravity works. These laws really are physical laws. These are the tools that NASA uses to go to Mars, so that they really do work. So what he wanted to do then was to figure out what was going on in the sky back around the year 0 AD. So then you get into various questions about what could have been in the sky back there. So most likely we're talking about something like April of the year 4 BC, as more likely the time. And we can go through a list of things and say what could have been up there. We have Chinese and Korean records to look at. So here's the three wise men. They're following the star. What could have been up there? So this is more of that same imagery. In the beginning, they were on camels. They've now dismounted and they're on foot with their gifts. And here's a Christmas star up here. Well, what it says, this is only slightly annoying. Okay. Yeah. I don't know how to get rid of the bar. Okay. There we go. So when they got to Jerusalem, and the three wise men got to Jerusalem. This is from the New Testament. The Herod secretly called for the wise men and learned from them when the star had appeared. He asked the wise men all about this star that was up there. And what this meant to Kepler was something that was profound. That meant that Herod, and probably you or I, didn't actually see a star up there. You have to go ask these people, the wise men, what it is they see up in the sky. What is it you're following? Wise men at that time, the magi, the word is magi in the Bible, could be translated as wise men, but it could be translated as magician. Magi, you can see the words are related, magician. And so one idea, the magi were actually sort of high priests that believed in astrology and may have known what was going on. But the lesson here is that the star that they were following is something that if you or I were there, we may not have noticed anything. It's not this brilliant star that's casting shadows on the space around it. Herod didn't actually know what the star was. The other thing that doesn't quite work out is that the star was in the east and the wise men were following the star. So here's Jerusalem, here's Israel here, here's Jerusalem right there. So if you think about the east is over here, it's, on this, it's that away. So if you're going on a long voyage and if you're headed east to go to Jerusalem, that meant that you must have come out of the Mediterranean Sea. Because if you're going east to get to Jerusalem, this is what's west of Jerusalem. So the idea Kepler derived from this is that the Magi probably were symbolically following the star in the east, but it was not following like a bright light in the sky and then following behind it, because they couldn't have followed something in the east for months unless they were under the water in the Mediterranean, and it couldn't have been something bright, or Herod would have already known about it. So what was around Israel at that time was the Babylonian Empire. Babylonia is where astrology was an ancient Babylonian religion. That's where it came from. And so that's, again, the religion that teaches us we don't have free will, but the positions of the planets in the sky determine our fate, our destiny. So the idea that comes from that, the Magi may well have been astrologers from Babylonia. So again, that's getting to be more and more conjecture, but Kepler was doing the best he could. So what could this thing have been? So if you look through the ancient Chinese, and especially the Korean records, good written records from this time, there's a number of things up there. So this is the constellation Orion. Everybody knows Orion. It's so bright. It's up in the sky in a good position this time of year. So you can see it. But there's this flash here. That's a meteor. So a meteor is something that makes a flash of light. It only lasts for a second or two, and then it goes away. So it's just a kind of a flash up there on the sky, a shooting star. The problem with this is everybody would see it, and the Magi took many months to get to Jerusalem, so that kind of doesn't hang together. A meteor is only visible for a few seconds. Next idea you might imagine, next thing that comes around on the sky are comets. So comets, we know today, are frozen snowballs. They're pieces of ice probably 10 miles across. They're leftover remnants from the building blocks that built planets at the birth of the solar system. So there was a lot of debris, rubble left over from the beginning. It's still out there. Every once in a while, they're mostly made of very, very solid water ice. The most common rock in our solar system is water ice, so cold that it's harder than granite. So you've seen, I think, a second Star Wars movie that came out. They were in a frozen ice moon or ice world. Those worlds really are out there in the outer solar system. So comets are chunks of ice, the size of a mountain, that have orbits that carry them too close to the sun, and it starts getting vaporized. Comets are visible in the sky when there's a bright one. They just kind of hang in the sky for weeks at a time. And I've seen a few comets. To ancient people and to me, they're very scary looking things. They look like ghosts or something. They don't look like it belongs up there. This is not dynamic. It just hangs up there above you. So in most cultures, comets, there's something deep in our core that tells us this is not a good thing. This is something to be fearful of. So it's generally bad news. I mean, it's possible the comets have the property that they're long-lived for many months, and they're out there in the sky. That and you can check this. So this is Giotto's Adoration of the Magi. This is a very famous painting from about the year 1000. And so here is the Christmas time in Bethlehem. The Magi have come up to Christ must be over here. And up here in the sky, this is actually Halley's Comet. It's a comet that comes back every now and again. So Giotto saw Halley's Comet, and he was inspired to make this painting as he thought the Halley's Comet was the Star of Bethlehem. The problem with that is everybody can see it, and it's generally thought to be a very bad omen. There's something about us that the sight of the comet scares us. It's ghost, like a ghost up there. Nova explosions every once in a while. So there's probably not a comet. There are exploding stars, which come in two types. I was a graduate student at MacAdam Observatory in West Texas, and a star exploded. It was a nova. And I was fortunate to be in an observatory. I got a lot of observations of it. That became my PhD thesis. So a nova becomes very bright. Nova means new. So they thought it was a new star. Now, we know now exactly what a nova is. It's a star sort of beginning to die, this big red star over here. And most stars on the sky, we don't notice this because we can't. If you look at the nighttime sky, about 2/3 of stars we see up there are actually two or more stars circling one another. They call it binary stars or triple star systems or more. So our sun is a little bit unusual. It's kind of born by itself. It's only one star. Most stars like company. And so they have what they call it a companion. So it reminds me of something from Doctor Who. So they have a companion. The stars don't age at the same rate. And this example, this is a dying star. This over here is a dead star. These are stars about the size of the sun or so. And material flows from here onto the dead star, and that causes a giant burp about every 10,000 years. So that's what we see as a nova explosion. The one I worked on for about a week was the brightest star in the sky, and then it faded away. This is something that happens every 10 years. It's 10,000 years or so. It doesn't hurt the star. This is back to the constellation Orion. This is Rigel. If you watch the original Star Trek, you know this is where all the sleazy bars in this part of the galaxy are. This is the star Betelgeuse, and this is a star that will become a supernova within the next couple million years. We understand stars that well. So a supernova is a star that blows up one time. It totally destroys itself and becomes amazingly bright. It becomes so bright, it's brighter than an entire galaxy with hundreds of millions of stars. We are in fact a factor of 4 outside the kill radius of this star. If we were 4 times closer to Betelgeuse, we know enough about these stars and what happens. If we were 4 times closer, we would be afraid of the star. I mean, this thing blows, it would hurt us. When it does explode, it will be visible in broad daylight for many months, and we'll be able to walk around at night for several years. So this is kind of a one-time thing. A star does this once. There are good Chinese, Korean records of supernovae They go off once. The problem's here. Everybody can see them. They're the brightest thing in the sky for a year. You can see it in daytime, and the next thing everybody can see it. So Kepler's idea of what the Star of Bethlehem was is what's called a conjunction. Conjunction, like conjunctivitis, means coming together. It means things appear to come together. So a conjunction of planets are when two planets come just by coincidence in their orbits. From our position at the Earth, they look like they're all lined up in a single line. And in really good ones, the planets appear to come to the naked eye, appear to come together and only make one planet. So a conjunction, if you believe that the planets are magic and control our destiny, if two of these magical planets come together and make one single really bright planet on the sky, that would be very, very powerful magic. And so Kepler proposed that a conjunction of Jupiter and Saturn lining up like this was what the Star of Bethlehem was. So there was a conjunction that NASA paid a lot of attention to in 2020, in kind of public relations to get people excited about the sky. Did anybody see it? If you're following the sky, so what did you know? Was this really awe-inspiring, or did you look out and look at it and say, "Oh"? Okay, yeah. So there's even okay. So it was mainly NASA PR working overtime. Got a lot of press coverage. Yeah, you could see a lot of photos showing both Jupiter and Saturn in the same field of view. So this is a time series. What the person here did was they took a picture of the sky about once a day, something like that. And so in the top of the picture, this was a few weeks before the conjunction. So the one on the left is Saturn, the one on the right is Jupiter. I can tell that because I know Jupiter is a bigger planet than Saturn. Jupiter is also closer to us than Saturn, so it's much brighter on the sky. So on the right, that's Jupiter following crazy path across the sky. And on the left, that's Saturn following a different crazy path on the sky. Remember, planets are kind of like cats. They're up there, they kind of do their own thing. They'll take your wishes under advisement, maybe. And so this shows a picture day by day by day as they followed their crazy paths, they are following Kepler's laws, but they're the crazy paths through the sky, and then they appear to come together as it did here. So this is actually a real picture. So they appear to come together on the sky. So that looks like what you saw. So yeah, you could see they were separate, right? Yeah. So the one Kepler proposed was a great conjunction where they came close enough together they probably would have looked like one planet. So Kepler's yeah, so this is let's go over that. So Kepler's proposal is this. So he figured out where the planets were in history. And so what this was what's called a triple conjunction. So the one that happened in 2020 was a single conjunction. They came together one time, conjunction. The triple conjunction is when, following their cat-like motions, ignoring the humans, the planets, although you can compute them with Kepler's laws, a brilliant deduction he made. The planets appear to come together on the sky, and then they pull apart again. Months later, they come back together again, and then they pull apart on the sky, and then months later, they come back together again. And so Kepler got the right answer here. He knew how to compute orbits. So this triple conjunction would have been May, September, and December of 6 BC. So in the biblical story, the Magi had to see the star first when they were home, and then they went off to Jerusalem and asked about this king and where to go. And then they saw the star the third time. They saw the star in Jerusalem, and then they went to Bethlehem and saw it a third time. So this was as good as Kepler could do. So indeed, he got the right answers. So triple conjunctions are something that are kind of head stuff. You can have one happening, and unless you or someone tells you, go look at that, you probably wouldn't notice it. It's not like a supernova above your head. So this satisfies this requirement Kepler had, that it had to be something that only the Magi would know about and Herod would not know about. And then it had to be spread out over a significant length of time. The details, well, this is 4 BC, 6 BC rather, and that isn't quite the lambing season, but nothing's perfect. So the last triple conjunction like this was in 1981. So the planets came together. You may have heard about the Voyager spacecraft. These are the two most distant living robots. And they were launched to take advantage of this 1981 triple conjunction. So they used the gravity of Jupiter and then Saturn to help push them farther out in the solar system. So the two Voyager spacecraft, one of them made a return visit as the bad guy in the kind of horrible first Star Trek movie. But basically, we think they're probably pretty nice spacecraft. They're still working today. They've been out in space. They've left the solar system. They're out in interstellar space. But this conjunction here made it possible for NASA to launch them. Next one is a couple of centuries from now, so I'm not waiting for it. So anyway, some topics that we've talked about. You can look up on Wikipedia. Saturnalia, the ancient Roman festival in the middle of the winter time. Johannes Kepler, a deeply beloved figure in the history of astronomy, of those founders of astronomy, Copernicus, Galileo, Newton. This Kepler was the one you would want to have as a college roommate. The others, maybe not. Herod the Great, his death. So that's one of the ways that there's constraints on the birth of Christ. Star of Bethlehem. If you go to Wikipedia, that page depends on who last edited it. And so what happens, anybody, you or I or anybody, can cook up your own theory about the Star of Bethlehem. Lots of people do. And then as soon as they cook up this new theory, they go to Wikipedia and they type it in. So it's actually hard to find the Kepler model I've talked about tonight on Wikipedia. But that is traditionally in astronomy what astronomers, if you press an astronomer, if you ask an astronomer, what was the Star of Bethlehem? They'll probably tell you the truth. Got no idea, don't know, didn't see it. But then if you ask again, tell me something about it, they will tell you about Kepler's idea that I've sketched out here. Then conjunction in astronomy, you have to go through astronomy, is when two planets come together on the sky. And those would be very, very magical moments if you believed that the planets were magic. And then the conjunction between Jupiter and Saturn, if you begin to type in Google conjunction Jupiter Saturn, it will complete the 2020 for you. And so it has a lot of images on Google Images. As someone mentioned, in a telescope, you could actually see Jupiter and Saturn in the same field of view. Google Images has a lot of that. So that's what it is. It's fun stuff. It's fun to think about the sky. What I really love about this is that the idea of this man with no instruments and no mathematics, only a love of the sky and a very, very deep religious devotion, was able to figure out in his lifetime these 3 laws of planetary motion, which even today NASA uses to cruise across the solar system, and then came up with this idea of the Star of Bethlehem. So thank you very much. Is it too cold to go out?
Should be okay.
It's clear.
Mostly.
Okay, so do you want to say something? Okay, well, thank you. That's my talk. We have time for a few questions.
Yeah.
And you will lead people across the telescope. So we have a student observatory that was request of Keith MacAdam. It's called the MacAdam Student Observatory. You can, if you have a group, you can book an observing session. And if you can phone the observatory and say, I got a bunch of scouts here who want to look at the moon. You can book special sessions. This session tonight is part of our regular month by month, second Thursday of the month. And it's a chance to go across. You can go to the very top of the parking structure across Rose Street, and our dome is up there. It must be slightly warm inside. Last I looked, it was freezing.
It'll be chilly, but
the thing to remember about the student observatory is the temperature inside is the same as the temperature outside, and according to my phone, is 32 degrees. So make sure you're make sure you're nice and warm if you go over there. And what's up? The moon? Ryan Nebula? Okay, yeah. Okay, so any questions at all? You're an easy audience. I got to tell you the history of this. I won't bore you very long. So I give lectures like this, introductory astronomy, all the time. And one day I got this unsolicited phone call from a person I didn't know. And she said she worked for a cruise ship company, and she can book speakers on various topics. And she said, we really want to find an astronomer. And then she said she thought to herself, what's the most, I need a really famous astronomer. And then she thought to herself, what's the most famous university in North America? And then she thought to herself, it's got to be University of Kentucky, because her father and Adolph Rupp were good friends back in the day. And she knew Adolph Rupp from when she was a little girl. And if you come from that perspective, UK must be #1. And so then she looked at, she got my name. So I got this gig doing talks on cruise ships for a number of times. So they didn't pay anything. And what she got, it was the cheapest cabin on the cruise ship, which was pretty bad. After doing it about 5 times, my wife said no more cruises for her. It was just that bad a cabin. So this was a talk I've given when the cruises happened to be near Christmas, a Caribbean cruise in Christmas. Now, the point of all that is this is a much easier audience because you didn't buy the drinks package. The audience I had to deal with wanted to make sure they got good value out of their drinks package. So that was an interesting, fun experience. Yes, sir.
So I know that Betelgeuse has been rising and dimming over many years recently. There's different theories on what that is. A lot of people think it might magically go.
Right, it could blow. Betelgeuse could blow at any time. What has happened over the last few years, it went through a great dimming and then has recovered. So we don't know what the symptoms will be before it blows. We know we're safe. We'll get a good view of it. So what is happening in Betelgeuse is a dying star, which is a very, very kind of schizophrenic environment. The core of the star, the energy is being made is small and very, very dense. But the part of Betelgeuse we see is almost as big as our solar system. But if you put our solar system in the center, Jupiter or Saturn would be somewhere near the outer layer. The star is very, very unstable. And there's solid materials are forming in its atmosphere. So the star is very, very bloated. And it has an atmosphere that stars have atmospheres. They're very important for understanding stars. And what happens is in these atmospheres is basically clouds form. So that's what was caused that great dimming, and then it recovered.
That was not subtle either. It was very.
Oh, yeah.
If you're used to looking at Orion, it was like, oh my God.
So I went out and looked, and you could see that. And I tell you what, I was hoping that this was the time, and I was going to see this thing blow. But then I thought, well, Orion will never look the same again, and that would be kind of sad if we only have 3 bright stars in Orion. But we understand how those kind of stars work. We understand it really well, and there are good models for what's going on. We can't pinpoint when it will explode. It's not going to be long. 1 million years is a long time in biology. The average species only lasts a couple million years. A million years in astronomy is not a tick of the clock. The Earth is 4.5 billion years old. A billion is 1,000 million. The galaxy is 10 billion years old. The universe is roughly 15 billion years old. So a million is nothing in astronomy. So we know it's going to be very soon by that standard. Okay, thank you. So we're going to go over the telescope. Oh, yes, it is. I left this, oops. Oh, so you're doing it. Sorry?
In that last bit of conversation, how many light years is Betelgeuse away from it?
1,500. So when it blows, well, we see it now about 1,500 years ago.
So you